All right, as you can see, we're finally doing proofs, and we have done a lot of proofs. I have done it. Um, so this check mark turns a little bit grayish for some reason when I do that, which I don't know how to fix, so I'm just gonna leave it like that. But general idea, the first proof I ever did, I showed you is this one, which I just realized I made a mistake because I did not use this font for this. Okay, better. Yeah. Anyways. Well, I already discussed what SAS is in the top, so you can look at that later. Anyway, we'll start with a rectangle, A, B, C, D, and you're usually given an image of it in geometry. So yeah, you're given an image, okay? So since I know what a rectangle, this is going to be given to you, the givens over here. This is like given for you to start off the proof. You can't start off with nothing. Um, always need to start off with something. And in this case, the givens are what we start, and then we have to prove this. Now, to tell you the truth, this is one type of proof. Do I agree with this type of proof? No, I don't really use this often, but it's a proof in geometry. And geometry has its uses, like um, in real life, something like pressure always doesn't have any like force unless you have like a geometric surface. Or when you're doing a panel method, all those panels need geometric inputs. A lot of things works on geometry, which is shocking, but it's true. Now, that's why I love this check mark. Okay, now let's actually get started. So in the beginning, I wrote this because in my geometry class in high school they made me do this stuff where you say draw AD and BD for no reason. Um, Nowadays I don't really give a crap about it, but and I never used these kind of statements in reason proof. I'm really questioning who would use this. I know who would use this. This is like if you were to go into real, I don't know, weird Euclid stuff, you can actually figure out more of this. But anyways, later on you just remove that. I think in the if I remember correctly, in the once for the first semester of my high school geometry, basically they stopped using this in the after the first half semester one. Semester two, we didn't do that. Anyways, from this you can get this because of the parallel theorem. Um, Which the reason why is I got the legs and I got the angle, so SAS is the right answer. So I still got it wrong, but uh, it's not due to this. No, this defines a triangle, and the SAS is here. All right, oh, we got it. Okay, okay. Sorry, I was right. So we use the parallel theorem. Oh, by the way, just so you know, certain books use it a certain way. You just have to do an if-then statement. So there's not really a lot of rules to this. Um, I'm pretty sure a lot of people have certain rules, certain professors do, just because it's easier to grade. Honestly, yeah, that's probably it. Now, I don't remember all that, so it's going off my head mostly. I'm just looking around and uh, some of my notes, and some ways to figure it out. And I figured it a lot, but you should really go to Euler's geometry if you want to really get into it. But I do remember some of the stuff, and I do have some textbooks on it. But yeah, for some reason, I didn't get any books that had a lot of these type of proof, which shame on me. Anyways, um, we get the Pythagorean theorem, and then that's the triangle over here. And if rectangle of opposite side, this is true. So the opposite side, AB, this is equal, and this is equal basically. So you have side, side, and you have an angle over here, 90 degrees, 90 degrees, 90 degrees. So these two triangles over here must be the same, is what I'm saying here. I do not know why I put A, B, C, D. That is a waste of space, I just realized. So let me edit this and just delete that because why on earth do you need it? Um, Now you're gonna see a clear difference of what I put in the given just because I'm lazy. Like for example, you're supposed to make each. I mean, some people, say that you're supposed to make each of these into like if it's a rectangle, then this is true, then this is true. But I get lazy and just put all that in a given because it's definition, right? It's just by definition. I'm just lazy about it. Uh, and it's okay to do that in my opinion for something obvious as a rectangle. I don't really give a crap. Anyway, here we start with the parallelogram again. And then here I did it, but I don't need to do it anymore. I could just put that as a given in my opinion. But because the parallelogram, come on. It's a definition of a parallelogram. Anyway, you have to draw a line, which I'm still doing for a while to draw that line. Later on, I'm not doing that anymore for obvious reasons. Reflexive property to claim this. As I said, you have to claim it. And then you're going to say DA equal BC and AB equal CD. And again, later on, I'm not going to do this, but I did it for this one, which is basically claiming these things over here. This segment over here is equal to that segment, and this segment is equal to that segment, basically. And then by that is all sides are accounted for as SSS. Now, if a triangle is congruent, then the corresponding angle is congruent, and I forgot to shorten this. Because I, for some reason, had it not shortened when I made it a long time ago, and I just copied and pasted that, and now it looks ugly. And now I can, okay. Now addition property is interesting. It allows you to add clearly, and that's why I needed to bring up addition property again. So you're adding up these two basically, and you can see that and then you just use substitution property to say this, which I just realized is not appearing as it should. Why are you doing this to me? Why? Just why? Just give me more space. Hopefully, it is showing up as I intended. Yes, it is now. Some of these images don't show correctly. It always does that. I don't want them to fix it because if they fix it, I have to redo all this again, which would be a pain in the ass. So just leave it be is what I'm saying. If Google's listening, which they're not. Anyways, isosceles triangle. So we're claiming this to be isosceles. So we know AB is equal to BC by definition. And we're going to actually add a sneaky thing here that D is the midpoint. Now, as you can see, I got rid of draw D is the midpoint of AC. You could have did that, and it would be a pain in the ass. Do I do it later on? No, and I'm not done with these, so I have to remember what to prove here, which I won't remember. I'll just make something up. Anyways, over here, I think that's what I did. Instead of doing draw. Now, definition of midpoint I have claimed here is basically this equals this. We discussed this in definitions. Anyway, side is what we got in this one, really? Yes, yes. Unfortunately, that's the one I got. Which now we can use corresponding parts of a congruent triangle are congruent. Basically means if it's congruent, then the corresponding, it's just I don't really like this because it's kind of obvious that's true, but you just have to put it in there because it's a proof now. This type of proof, you need to do it. Anyways, over here, it's next one. Where this one is interesting. I'll tell you why because of this over here. Anyways, I made that whole thing up because it's actually pretty useful in solid mechanics. Anyways, parallel, and then this is what I'm going to give you. And then triangles, okay? And then reflexive property claims this thing. Now, this is the first time a reflexive property can give you an angle, which is true, which is a little bit more interesting, in my opinion, because you can actually see the change when you write in the statement, unlike a line, which you're just claiming itself to this, basically. Now you're going to write if two parallel lines are cut by a line, then corresponding angles are congruent, which has to be true if they're parallel and you cut it. This is one of the things that you can't really prove is just observe and define. Uh, but you can observe it, calculate it by hand, and see that that's true. So we're just going to put that definition basically, and I did put it in the definition. Now by AA, which is angle, we can say that this is congruent. Now, why is that anywhere relevant? Okay, here's a question. Here's a good question, kind of. So I'm going to assume an engineer got the right balancing right. Um, to get this kind of weird once again displacement from just a 500 force, that's kind of weird because you're gonna have to. It means that it's kind of like, but kind of yeah. We're just saying theoretically it's possible. Okay, we're just gonna say it's possible. Um, that's why I said don't worry about the physics about it. Some some not crazy, some decent, a good engineer has solved the inner workings of it with probably some skin, probably some, I don't know. It's definitely not a spring, but technically is a spring because the skin is a spring. But basically, some systems to make the displacement all align and then like this. So it's very stiff or something, and the deflection is very minuscule, so it can be estimated as like a triangle or whatever. It's already very small anyway, so actually it's kind of possible with this setup that I made. Anyways, keep on talking about the shenanigans. So if I have first, usually this the question I got when I was doing solid mechanics, this is flat, and that's fine. It'll give the same thing, but I'm just giving a more general case for some weird reason I decided to do this. Anyways, if this was angled, and for some reason you have something like this, and now you know from this that this goes onto a log of triangle because the displacement has happened. Um, you know from this that this is true, basically. As a three-tong, but it doesn't matter if you add another one over here. It's basically the same thing, right? I hope that makes sense, right? It's the same thing. So first thing I realized is congruent, which means I can get a ratio, and it'll be the same thing. Now, what kind of ratio would make sense? Let's first get rid of 1 millimeter from each and every one. Why would I want to do that? Well, that makes a smaller triangle over here, right? A smaller triangle that actually looks exactly the same as this form over here. Now I can do my math, which is L divided by, we know that uh, this is B1, base 1, base 2. Base 2 minus base 1 is a new ratio that we're looking for. Now L divided by 2, this is Z now. And this is what we're looking for because Z plus 1, 1, but Z plus base 1 is going to give you the answer, right? So this Z, if you rearrange it, you get this, and look at that. The length cancels out. What that means is the size of the length doesn't matter for this, but the where that length is actually contributes, which is the half over here. Now imagine if that was a fourth of the way. This constant, constant equal 1/2 for this would be different. Now, if this was 4, well, the chips are 4, so it'd be 1/4 of the way. And so on and so on. If this was 3/4, then this 3/4, right? So it's very wear dependent, assuming all the materials are engineered to perfection to do this kind of deflection. Excuse me. And we add back to base 1 and we get 3, basically. That's pretty much it. Okay, so next up we get this parallelogram. E is the midpoint of AC. I'm giving that to you. And BD. Okay, ABCD is a parallelogram. Okay, that's the givens. Okay. Now, at first, I was going to do AA, then realized that I should have made this question easier. Anyways, what happened to my tablet? Okay, so vertical angles are congruent. This is a fact we discovered. That means this is equal to this, and this is equal to this, basically. That's one of our definitions long ago. Indirect lecture. Probably should probably put that in the list. Actually, I don't want to, but I should. Anyways, SAS also means this. So congruent, then this. I didn't explain this, but if it's congruent, it's obviously similar. And for some reason, I chose to be similar, and I was stubborn about it. I just said I just didn't want to change that, so I decided to leave it in, and now I'm suffering through it. Okay. Anyways, so this triangle equals this triangle. Basically, this triangle equals this triangle, and this triangle equals this triangle is basically what I'm saying. Well, clearly that would mean that the corresponding parts are good. And then how did I get that this triangle is okay to this triangle? Well, basically by angle and then angle, and we knew that oh yeah, because it's a midpoint, so this equals that, this equals that. So we have a this. So we have a box that makes this equal to that. Yeah, basically, yeah, that's all correct. Anyway, after that, you have to call in AC equal AC reflect property. I really want to just get rid of this, but that's later on when we're comfortable of getting rid of the obvious reflex claiming stuff, which is like, why the hell do I do that still? I don't know. Anyways, then we can say by SAS that this triangle is equal to this triangle. Yeah, I'm gonna put a lot of stuff in given if you couldn't tell later on because I'm lazy and I do not want to do an if-then statement like if is a parallelogram of this is by definition this is true by parallelogram. Parallelogram definition says that I'm too lazy to do that shenanigans. Yeah, so I'm done because I didn't finish the kite example. Oh, the hell is uh oh yeah, there's a shortcut. So this is a shortcut of it that I forgot that existed. No, I didn't forget, I just didn't remember how to write it. So there it is. I remembered a long time ago. I was looking for it all over my notes, but I couldn't find it. How funny. No, it's too late to, I mean, I kind of like it that way, so I'm not going to change it, but I should have added this instead of this long thing. I should have but it's too late now. I don't want to change it, so we're going to keep it like that. Yeah. So as you can see, it's all about does it make sense? After it makes sense, you can do an if-then statement of anything you pretty much, no, not anything, but as long as it's clear and makes sense and it's logically sound and it's probably by definition, you know what I mean.